Let's look at odd or even program now. So this is a fairly straightforward program, but only difference when compared to add program is that now you have a control point here. If it is true, you will execute this, otherwise you will execute this part. Okay, so there is a branching. So we will see how uh, it translates into low level instructions in such a case. So as you can see, there are two global variables, num and result, but we also have added t1 and t2, which are temporary variables. The reason would be obvious in a moment. So the first statement translates into in num to receive the input and store it in the variable num. And the second statement would involve multiple instructions. Why do we need these multiple instructions? Because you are computing one remainder and then you are assigning it to result. So there are three variables involved. In fact, 2 is basically a constant. So if you want to use 2, then first you need to load it into a temporary variable so that it can get into the register. So it needs a temporary name, temporary location to be stored. That's the reason you need this T1. T1 stores this value 2. So we are assigning a T1 value 2, and then we are loading num, we are loading T1, and then we are computing the remainder operation. So num modulo 2 would give you a result 0 or 1. So that result is stored in the first register, that is R1 itself. Okay, and that is being assigned to the result. So this carried back to the result. So this is the set of 5 instructions for this single statement. Okay. Once this is done, once this is done, then we are coming to this particular part. Here is where we need to concentrate. If you look at, we are checking whether result is equal to 0, right? If this is the case, 0 also has to be loaded in some part of the memory and then transferred to the CPU register. So how do we do that? So we assign the value T2 to 0. That's the reason we have declared T2 here. And then we are loading T2 to R10. That is 0 gets loaded to R10. Now we have result and this both result and the 0 on the register. R1 contains the result, okay, and R10 contains 0. And now we are ready to do a comparison. So when we do the comparison, what happens is we check the equality. In this case, it's a equality. We check equality of R1 and R10. So the result could be true or false. Okay. Now, if it is true, then I want to go ahead and then continue with the sequence of instructions. But if it is false, I want to move to some other point. So what happens is we will check whether if the result of it is false. If false, then we say that no, don't follow and execute the statements. Instead, go back to some other point. That point is labeled by L1. So basically, this is the false case. So you are being redirected to the false case, so that no, you don't continue to execute the statement which are part of true case. So this part is done, and this jump is being made if it is false. Suppose it was true, what would happen? You would continue, and then you would say that now let's say I'm setting the output even, right? I'm giving the output even, and then but I am not supposed to continue. I am supposed to go out of the else part without executing it to the exit point, and that is the exit point here we will see. So at this point, what happens is you have executed the out statement, that is even, you have printed, and then because it was true, check it. The previous if was true, check it, and then now jump to L2. So L2 is here. That means after executing this, I am going to jump out. But if it was a false case, you would come over here. If it was a false case, you would come over here, and then you will print odd, and then anyway you will continue with L2. You will reach the exit point as it is. Okay, so you can see that there are two jumps depending upon whether it's true or false, right? Because you need to execute the true part and then go to exit point, or you can have to jump to else part and continue along. Okay, so there is one of the jump is needed, and this is how this works. Now let's see like how to um, we will see the demonstration. So here is the source code program, and here is the um, low level instructions which was explained just now. Okay, and let's get started. So as you can see, the global variables are are created in the data segment, because all the variables are global now. And then we'll start. So we'll take the input. Let's say we are typing the input 5. 5 is an odd number, and we are supposed to get the result odd. Okay, so let's submit that. So the num is 5, and then now the T1 gets loaded with 2. Now you can see that num is getting loaded to R1, and this T1 is getting loaded to R3. Okay, so we want to do the modulo operator 5 modulo 2. That is the next step. So which is the rem operator, remainder operator, and then it updates the value to be 1. So because it was odd, we see that the value 5 modulo 2 gives you 1, and this 1 is stored back to the result. Okay, so now we are going to assign T2. T2, as you know, it's basically because the 0 has to be stored somewhere. So we are assigning T2. T2 becomes 0 now, and then this gets loaded to R10. Okay, now we are going to check the equality of R1 and R10. So the result is 1, and if it is 0, then we know that it doesn't match, so it is odd. 1 equal to 0 is odd. So this is what we want to do now. So the equality check is happening. When the equality check happens, now that it can be either true or false, because 1 is not equal to 0, so it will be false. So we will be redirected to the else case. We will be redirected to the else case. So, and then we come over here, and then we print odd, and then continue, and then exit. Suppose if we were to give an even number, what would have happened? So let's check that particular case also. Let's say that now we are giving a input 4. Let's submit that value. Now let's go on assignment. Exactly the same thing happens. Now 4 gets loaded, then 2 gets loaded, then 4 modulo 2 happens, which results in a 0, and this is stored in the result. And now assign T2 is happening, because you need to store the 0. Now we are checking whether R1 and R10 are same. That is the result, whether it's same as 0. Result is 0. If result is 0, it's a true case now, so the false case will not happen. So what will happen is it will continue here and print even. And once it's done, because it was true, it has to exit. It has to go to the exit point, which is L2. So it moves to the label L2, and then it exits. So we have seen both the cases of true or false and how it works.